Welcome to another video. In this video, we're going to be finding the largest integer or the largest number, which is definitely going to be an integer, which is the product of some integers, and the sum of those integers is 1976. Obviously, you could tell that this problem is from the International Mathematics Olympiad of 1976. Okay. We are going to do a smaller problem so we can have a better picture of the bigger problem. Let's get into the video. So in order to understand this problem, I would want you to think about if we change this big number to a small number. So this is what we're trying to do, so you get the picture. We want to put some numbers together. If you add them together, you're going to get 10. But if you multiply them together, you're going to get another number. We want to see the biggest number we can generate. That's it. That's all we're doing. Okay, so we're going to say the sum. So this is just an example. Okay, and this would be the product. So look, let's start with this. Let's say I try 9 and 1. I know that 9 plus 1 is going to give me 10, but 9 times 1 is 9. So let's try 8 and 2. If I do 8 plus 2, I'm still going to get 10, but 8 times 2 gives me 16. So automatically, I know that 16 is the number I'm looking for because we're looking for the largest integer. Okay? So all the numbers we're dealing with are integers. In my explanation, I'm going to take you to a path that does not involve integers, but it is just the universal rule for this, but let's just stick to this example. Now you can take a break if you would like and just try it. When you find your actual answer, come back. Remember, we're dealing with integers only, okay? But if you don't want to take a break, let's do this together. So now I have found that these two will give me 16. What if I do 7 plus 3? I'm going to get 21. What if I do 6 plus 4? I'm going to get 24. What if I do 5 plus 5? I'm going to get 25. So looking at the options I already obtained, 5 plus 5 giving me 25 will be the highest integer that I can generate, as long as I follow this rule of the sum of those numbers being 10. However, the question did not say that the numbers you're adding together are just two numbers. You could be adding up 3 numbers, or 4 numbers, or 5 numbers, as long as they are positive. Oh, positive integers. Okay, so I have to say that every integer is positive. Let's add that to it, okay? Because if I don't write that, someone in the comment section is going to say something about that. Okay, so all positive integers. Okay, now, so here we go. What if we're not dealing with just 2 numbers? Can we write 10 as 3 numbers written together? Yeah, we could do I'm trying to see the one that's going to give us the biggest one. Why don't we do 4 times 3 times 4 plus 3 is 7. 4 times 3 times 3. Okay, so we could say 4 plus 3 plus 3. This is going to give us 10, and the product of this is going to be 36. Nice. Looks like this is the leading candidate right now. Now we could do 5 plus 3 plus 2. This is going to be 50. That's 30. Okay, it doesn't look like it is the highest. We're trying to do, what else can we do? I'm trying to see how many more I could, what if we do a lot of 2s? What if we do 2 plus 2 plus 2 plus 2 plus 2. That's 2 times 2 times 2 times 2 times 2. That's 32. Oh, it's still less than this guy. What if we do more threes? 3, no, it's not going to work. If we do 3 plus 3 plus 3 plus 1, that's going to give us 3 times 3 times 3 times 1. That's 27. No. So far, our highest product is 36. And the next highest product is 32. And the next highest is this one. No, look, these three numbers have something about them. This number is generated by 4 times 3 times 3, which we can write as 2 plus 2 plus 3 plus 3. Now notice all the numbers in the picture. They are all prime numbers, right? Notice all the numbers in this picture. 2 is a prime number. Look at all these numbers, prime numbers. It looks like when you first express a number as the sum of prime numbers, you can then make the product as big as possible, because then you can have a higher exponential expression. Because right now, this number can be written as, so this 36, so these are the candidates. You got 2 squared times 3 squared. That's what gave us 36. And this number here equals 2 to the 5th. That's what gave us 32. And then the third one is just 5 times 3 times 2. But you can see primes all in the picture, right? At this point, this is what we got. So what if we change this number to 1976? What kinds of numbers will we try to add together? Should we do 5s? What if we change this number to 20? I am trying to walk you into figuring out where we're going with this problem, because this problem is pretty easy if you know the key to getting the highest number when you have to multiply something repeatedly, because multiplying different numbers will not help you. What helps you is multiplying the most of the same number. Okay, notice how we multiplied 3's here and 2's here, and we got the highest possible number. If we change the total sum to, let's say, 11, now see what happens. Okay, I just want to do a quick deviation here. Let's change this to 11. Suppose the total is 11. We can do 3 plus 3 plus 3 plus 2. Right? That's going to give us 11. But 3 times 3 times 3 times 2 is going to be 54. Now, tell me, what other combination do you have that's going to give you that? It doesn't look like we have many. Right? It doesn't matter what numbers you use, it is impossible for you to generate a bigger number than 54 as long as you're using integers. 4 times 7 is 28. 8 times 3 is 24. 9 times 2 is 28. 3 times 3 times 3 times 2 is the biggest one, 54. What about 5 times 5 times 1? No. So what about 2 times 2 times 2? No. So this is your best candidate. Notice how the more 3's you're getting, the better your answers are becoming. The reason is because 3 is a very cool number. Okay, now let me erase this and tell you why 3 is the best candidate. The secret to this problem is hidden in the exponential function. Remember that exponentiation is just repeated multiplication. What you're going to be doing is you're going to be multiplying and multiplying and multiplying, And based on our little experiment, it looks like if you repeat a number, it tends to be higher than if you pick random numbers and multiply. So if you would like to repeat a number, what number would you like to repeat? Well, based on the behavior of the exponential function, the best number to repeat in this case will be e itself, which is the basis or the base of the exponential function. So now look at the behavior of all exponential functions. Now let's say the base is not e, okay? So look at this. This is our exponential function, e to the x. Let's say we're not using e to the x, we're using another number, x to the e. Let's keep it cool. Clearly, one of the times that this and this will be the same would be when this is actually here at e, where x equals e, so that these two will be the same. Otherwise, you'll have different values. Notice that almost at every point, what you keep getting is e to the x is above this line, x to the e. Because the exponential function graph tends to rise the fastest as long as you are doing repeated multiplication. If you keep the base as e and you have limited resources, not if you have unlimited resources, because x to another power would be a lot faster, right? But if you have limited resources and we want a graph that grows the fastest, you might be thinking of taking base e. The only problem with our problem is they're telling us that every number we use has to be an integer. So you have to immediately think what integer is closest to 2.718. There are two integers involved, 2 and 3. You see why the answer we got when we did the 10 problem involved 2 and 3, because those were the two closest integers to e. But now, we don't have to pick 2 because we don't have to use both of them. We could get as many 3s as possible. We couldn't get as many 3s as possible from 10. But looking at the number 1976, there are a ton of 3s in it. So you want to get as many 3s as possible, which are the closest integers to e, and whatever is left has to be in terms of 2. Does 3 divide this? Let's see if 3 divides this. This is 20 plus 13, that's 23. 3 does not divide 23, so there must be a leftover of 2 or 1. In fact, it's going to be a leftover of 2 because 3 divides 21. And that's exactly the trick to this. So let's write it here. The key to this problem is using as many integers close to as possible. As many integers close to e as possible. 3 is the best candidate. So the question you're going to ask yourself is, how many 3s am I going to get in 1976, right? So we just have to divide 1976 by 3. That tells us the number of 3s we're going to be adding. 3 plus 3 plus 3 plus 3 plus 3 plus 3, that number of times. Okay, let's do that. We say 1976 divided by 3. What are we going to get? We know 3 divides 19 6 times, divides 17 5 times, divides 26 8 times, and there's a remainder of 2. So that means that 1976 is 3 plus 3 plus 3 plus 3 plus 3, this number of times. Then there's going to be plus 2 in the end. So we say that 1976 equals 3 times 658 plus 2. So if we're going to do the multiplication to get the largest possible number, the number we're looking for, our n, largest, max, let's call it max, n max is going to be equal to 3 times 3 times 3 times 3, this number of times, which is 658, then we're going to multiply it by 2. So our final answer will be 2 times 3 raised to power 6, 58. And this is the largest possible number that we can generate if the sum of the added integers must be 1976. Never stop learning. Those who stop learning, stop living. Bye-bye.